So what I want to do is take a look at this problem here. See, the surface of an island is defined by the following functions over the region in which the function is non-negative. Find the volume of the island. And we may want to produce a graph. I'm not going to use Maple. I'm going to use Mathematica. So we have a couple of these we'll look at. So let's take a look at this very first one here. If I jump to Mathematica, what I'm going to do is I'm simply going to produce a graph of this so I can get an idea of what it is I'm looking at. So here's some Mathematica code for you. And here's my island. So if I rotate this thing a little bit, what I can see here is this is 0. So this is like sea level, and in a way you can think of this as the ocean floor, I suppose. And here is sea level at 0, 0. And you can see it's just a little bit above what appears to be the ocean floor. So it's like cutting this roughly here and looking for the volume of this island that's above sea level. That's really what we're talking about here. So you can kind of imagine a plane cutting this thing, and part of it goes down to the ocean floor, and part of the island sticks up. So in order to find where that actually happens, what I need is e to the negative x squared plus y squared over 8. This has got to be greater than or equal to e to the negative 2. That's the only way this is going to be positive or 0. That would then obviously imply that a negative x squared plus y squared over 8 is greater than or equal to negative 2, which means x squared plus y squared is less than or equal to 16. So this is a circle with a radius square root of 16, or a radius is actually 4. Also notice that this is probably going to be a lot easier if I switch to polar coordinates, and this right here is r squared. So what I want to do is think in terms of this island thing again. I know that my radius is going to be 4, but I'm going all the way around, so theta will go from 0 to 2 pi. So I'll have a double integral. Theta would be from 0 to 2 pi. The radius will go from 0 to 4. And remember, this is r squared, so I will be working with e to the negative r squared over 8 minus e to the negative 2 times r dr d theta. So that's my setup for this particular integral. Okay, so this is going to be the double integral 0 to 2 pi, 0 to 4. I don't necessarily need to break this up, but I'm going to, because it might be a little bit easier for you to see. R e to the negative r squared over 8 dr d theta minus the integral 0 to 2 pi 0 to 4 of e to the negative 2 r dr d theta. So I'm going to go ahead and do this piece. Straight u substitution. If I let u equal a negative r squared over 8, then du equals a negative r over 4 dr, which means a negative 4 du equals r dr. So now I can take a look at this negative 4 times the integral of e to the u du, which is just negative 4 e to the u, which is negative 4 e to the negative r squared over 8 evaluated from 0 to 4, which is going to be, see, negative 4 times e to the negative 4 squared is 16 over 8 is negative 2. Minus a minus, so plus at 0, this is just 1. So I can't forget my negative 4. So it's going to be, well, the negative is already there. I just forgot to distribute the 4. So this is going to be 4 times 1 minus e to the negative 2. So now I need to integrate that with respect to theta. So I have from 0 to 2 pi of 4 times 1 minus e to the negative 2 d theta, which is obviously just 4 times 1 minus e to the negative 2 theta from 0 to 2 pi, which is going to be 8 pi times 1 minus e to the negative 2. At 0, it's going to be 0, so that's all I have to worry about. Now, this is not my solution. This is just the solution to the first piece. Now I need to worry about this, but this integral is going to be a lot easier. And let's not forget about this negative sign. It'd be really easy to drop that guy. So I'm going to have the integral from 0 to 2 pi, 0 to 4. Let's go ahead and put that negative there so I don't forget it. This is e to the negative 2 r dr d theta. Now, with respect to r, this is just going to give me e to the negative 2 r squared over 2 from 0 to 4, which is just going to be 8 times e to the negative 2. So now I'm going to have, I'm just leaving this negative floating around out there, a negative integral of 0 to 2 pi of 8 times e to the negative 2 d theta, which is going to give me a negative 8 e to the negative 2 theta from 0 to 2 pi, which is obviously just going to be, well, I'll do it right here, a negative 16 pi e to the negative 2. So that is the solution for, whoops, didn't want to do that. That is the solution for the second piece. So now I want to combine them, and I will get 8 pi times 1 minus e to the negative 2 minus 16 pi times e to the negative 2. Now this I can do a little simplification with, which I will work with a little bit. This is going to be 8 pi minus, whoops, 8 pi, yeah, not enough room there, sorry. 8 pi minus 8 pi e to the negative 2 minus 16 pi e to the negative 2, which is going to be 8 pi minus 24 pi e to the negative 2, which, sorry, I'm running out of room here. I'm going to pull out, what do I want to pull out? Let's pull out an 8 pi. This could be an 8 pi times 1 minus 3 over e to the negative 2. And I think that's where I'm going to stop. There's my solutions. Obviously, there's a couple more formats I could put it into, but that's good. That looks really good like that.